Example 1, sketch the graph of the function f of x equals x squared minus 5x plus 6 over x minus 3 and analyze its behavior near its non-permissible values. So the first thing I need to do is see if this simplifies. So to do that, I'm going to factor the numerator, which it does factor. So we're going to get x minus 3, x minus 2 over x minus 3. And we see something cancel. And that's the part that's going to tell me if there's a hole in the graph. So x minus 3 is still a non-permissible value. But because this cancels, it's not going to be a vertical asymptote. So in my simplified equation, I have f of x equals x minus 2, where x cannot equal 3. It's important that you have your restriction in your as you're writing your equation. If you didn't see the original equation, you wouldn't even realize this restriction was here. So what we're going to do now is find the point of discontinuity. The point of discontinuity is going to occur at the NPV that was canceled out, okay? So this means, let's just say here how to find the y value though. So to find the point of discontinuity, you substitute the non-permissible value into the simplified equation to find the corresponding y value. So I know that this has a hole in the graph or point of discontinuity at x equals 3. That's my restriction. So my simplified graph is f of x equals x minus 2. So we're looking for the y value. So if you just want to write at y equals x minus 2, to find that y value, we plug in 3 here and we get 1. So we have our corresponding point of 1. So 3 and 1 is the point of discontinuity, or you can abbreviate that later. Okay, so that means that I'm going to make sure I put a scale in here, and I'm going to go to 3 and 1. I was counting to 3 already there, and I'm going to put a hole in the graph. All right, now I'm going to go back and graph this. So just using y equals mx plus b, I have a y-intercept of -2. I have a slope of 1. So I go up 1, right 1, up 1, right 1, up 1, right 1. I would have went through that point anyway. I just don't put the point there. Up 1, right 1. But that does confirm that that makes sense, and then that would be in the right location. Okay, so now we're going to connect it, making sure my line, though, does not go through the actual circle. You want to either label that on the graph, or if it's labeled here, you're fine, but I want to make sure that point is easy enough to see. So that's a key point. And again, why is this not a vertical asymptote? Because this canceled out, okay? Why do you need to write the restriction here? Had you not wrote the x minus 3, you would just think it's the linear line and not have realized there was a hole in the graph and that it even maybe came from a rational function.